Hello, can you hear me?
Yes.
How are you all doing?
Hello, Professor.
Good.
Give me a few minutes. Let me check their names. Check their names off. Jordan Lewis. Oh. Winder. Watford. Yeah, Lane. Who's Lane? Who is Teyahon Lane? Whose name is that? Is she Teyaton Lane? No response. Okay. Brown. I got Brown. I got Simpson. Okay. All right. Let us begin. I couldn't make it to campus today because I'm not feeling well. So I decided to have this remotely. Let me write this name down. Tahir Hon Lane. Okay. So let me show you what we have this week. Let me start from there. I'm going to take you to the course website. Making sure you're seeing this. Okay, good. So this is the work we have. This is week 6. So complete the assignment, the homework 3 and 4. I have extended the due date 3 times, so it is due this week. So complete them, homework 3 and 4. Then you have test 1 that is due on Sunday, and the Excel assignment 2 due on Sunday as well. The classwork 6 is due tonight, but you can still submit it tomorrow. I will accept it. And you can have access to all this by going to the models. Once you're in model, we are now in model 4. But you're gonna see all these assignments that here, Richards. So you can have access to them by going to the model. So they're all here, and we will begin probability this week. So I'm gonna add more assignments here next week for next week. But for this week, you only have the homework 4, homework 3, test 1, and Excel assignment 2. So let us begin. Excuse me. Now, we start from what we have tonight, empirical rule and the Chebyshev theorem. Now, empirical rule state that for any data having a distribution that is approximately bell-shaped, then the following properties applies. At about 68% of all values fall within one standard deviation of the mean. About 95% of all values fall within 2 standard deviations of the mean. And about 99.7% falls within 3 standard deviations. So usually when using empirical rule, we consider data entries that are more than 2 standard deviations to be unusual. Sorry, to be data entry that is more than 2 standard deviations to be unusual. Let me explain what I mean by that. If you look at this chart, see, it is bell-shaped or normal. See, all from here, from this pot, let me show what I mean. From this pot here to this pot, if you add all the numbers there, let me write them down, so we can add them. We got 13.5% plus 34%. Okay, let's add them all. Then from this one, so from here to here, 13.5. So you can see on the left side, they are represented by mean minus 2 times standard deviation. On the right side, mean plus 2 times standard deviation. So any data value that fall outside this range, like if it fall here, or here, which is outside this range, we consider it to be unusual. So now that what he's saying here, that data entry that lies more than 2 standard deviations of the mean are considered unusual, while those that lie more than 3 standard deviations are considered very unusual. But if a data value fall within this limit from here to here, it is considered to be usual. Anything outside it is unusual. Okay. So empirical rule, we use it only for this kind of distribution. It must be either symmetric or normal or bell-shaped. If the question did not mention that the distribution is bell-shaped, or that the distribution is symmetric, or that it is normal, then you cannot use the empirical rule. So the general formula we use for empirical rule, so in general, we use the following equation to express the range of values of K, or values within K standard deviation around the mean. The equation is mean plus or minus K times standard deviation of. So this symbol represents the mean. This one represents the standard deviation. K represents the number of standard deviation that the data value falls away from the mean. So the negative part is just to tell you that it is on the left side. The positive on the right side, as you can see from here, everything that have negative are located on the left side. Those that have positive are located on the right side. So each time we are solving an equation that involve the use of empirical rule, first thing we do is to find the answer to these formulas here. Once we find the answer to the formulas here, we can answer the equation. Okay. We'll come to that again. Let me give you a highlight on Chebyshev. Remember, the empirical rule is used only for normal distribution. That is a distribution that have this shape. But the Chebyshev, we use Chebyshev for any distribution. It doesn't matter whether it's normal or not normal. So if the question did not mention that the assumption that the distribution is normal, or that it is bell-shaped, or that it is symmetric, that means that you're going to use Chebyshev, not empirical. But if you mention those things, then you use empirical. According to Chebyshev theorem, it says the position of any data set lying within K standard deviation, where K must be greater than 1 of the mean, is at least 1 minus 1 over K squared times 100%. So according to Chebyshev, we have that 75%, at least 75% of any data values fall within 2 standard deviation of the mean. At least 89% of the data values fall within 3 standard deviation of the mean. At least 94% of data values fall within 4 standard deviation of the mean. So you can compare it with what empirical rule is saying. Empirical rule says 68% will fall within 1 standard deviation of the mean. 95% fall within 2 standard deviations, and 99.7% of value fall within 3 standard deviations. So you can see the difference between the two. So now, in general, we use the following equation for both to express the range of values, just like we did for the empirical rule: mean plus or minus K times standard deviation for population. Now, for Chebyshev, sometimes the question might not give you the K. So that means you have to estimate the K by yourself. In that case, you use this formula. Either you use this one or you use this one. Now, having explained that, we can begin to solve question. But before that, does anybody have question for me? Any question for me?
No.
Okay, good. So let us start then. So we have the past result from the National Health Survey suggests that the pulse rate, that is the heartbeat per minute of women, have a mean of 76 and the standard deviation of 12.5. Assume that the distribution is symmetric. See, he mentioned that. He said, assume that it is symmetric. That this statement here tells us that we're going to be using empirical rule. He said, find the minimum and maximum usual pulse rates of women. Okay. Then determine whether the pulse rate of one term should be considered unusual. Now, to answer this question, remember, first of all, you write the mean. Mean, they tell us that the mean is 76 and that the standard deviation is 12.5. The first question says, find the minimum and maximum usual pulse rate for women. Usual, I explained in my idea that the usual is lie within 2 standard deviations. See? So that means we want to find the answer to this formula and then answer to this formula. And then that will give us the answer we're looking for here. So the first one gonna be mean minus the mean is right there. Let's pick it from here. Mean, okay, minus 2 times the standard deviation of delta, okay, 2 times this delta, and that'll give us the mean is 76.5, 76 minus 2 times the standard deviation is 12.5. So let me write it down. 76 minus 2 times 12.5. So we can go to this place and get our result from the calculator. So we got where's my calculator? Okay. Yeah, that is somewhere. Give me one. Let me get my calculator. Give me 1 minute. Okay, right here. Okay. So we have this. You can see the screen, right? I believe the calculator. Yep. So you got 76 minus 2 times 12.5. 2 times 12.5. 12.5. Okay, that gives us 51 for the minimum. 51 for the minimum. We got 51 right there. 51 bits. 51 bits per minute. Now, we'll repeat the process for the upper range, for the minimum. For the maximum. So when I just copy it and just change it to plus. Okay, just change this to plus. Plus. Then the plus gonna be here, plus. And that will change our answer to, so I'm gonna go there again, and the calculator. Okay, 50 plus sign 101. 101. So 101 bits per minute. So 101 bits per minute. That means that because the question was find the minimum and maximum usual pulse rate for women. So the minimum and maximum pulse rate. So the minimum is 51 bits per minute and the maximum is 101 bits per minute. So we answer part A. Now part B says then determine whether the pulse rate of 110 will be considered unusual. Okay, well, you can see that the minimum is 51 beats and maximum is 101. So a pulse rate of 110 is bigger. It doesn't fall within the range. So the range is, range is 51 to 101 beats per minute. So the pulse rate of 51 is unusual. A pulse rate of 110 beats per minute is unusual because it falls outside the range for women. It fell outside the range for women. The range, is bigger than 101. It doesn't fall within the range. Any question? Any question on that? Okay, good. No question. Very excellent. Now, let's look at the second example. It says, the mean speed of a sample of vehicles along a stretch of 67 miles. The mean speed of vehicles along a stretch of highway is 67 miles per hour with a standard deviation of 4 miles per hour. Assume that data set has bell-shaped distribution. See this statement here. It says, assume that it's bell-shaped. That means you're going to use empirical rule. And it says, estimate the percent of vehicles whose speed are between 63 miles per hour and 71 miles per hour. Assume that data sets are bell-shaped. Okay. Now, part B says, suppose that the number of vehicles in the sample is 75. Estimate the number of vehicles whose speed are between 63 miles an hour and 71 miles per hour. Part C says, in a sample of 25 additional vehicles, about how many vehicles will you expect to have the speed exceeding 71 miles per hour? Again, this is empirical rule because it says here that it says to assume that data set is bell-shaped. So let's start. Solution. So this one, the mean, let me get the symbol for the mean. The mean, I'm gonna get it from here. You say that here that the mean, okay, the mean is 67 miles. So I'll make this 67 miles, and the standard deviation is 4 miles per hour. Now, as usual, we're going to use this formula that for given for us. See, the same formula that we have here. So we're using this formula, plus or minus. See, mean minus k standard deviation and mean minus. Okay. Now, but before you can do this, k can be 1, 2, or 3. Before you can do this, I want to show you something. I'm going to bring the charts for empirical rule chart down here. Let me bring it. Okay, this is the chart, right? Let me bring it here. Copy this and paste it under. Okay. So to answer this question, we need this. We need to get, and first of all, we have to get the answer for these formulas here, for all of them. Then we can be able to trace our answers. Okay. Now I'm going to move this down a little bit so that we can have enough room for this. So let me move them down. Okay. So we can have more rooms here. Good. Now, so to answer this question, that they say estimate the percent of vehicles whose speed are between 63 miles per hour and 71 miles per hour. We need to, first of all, get the answers to all these formulas here. The first answer we get is, they say, is the mean. And we are told that the mean is 67. So we go right there and put 67. Yeah. You go right there and put 67. 67. So this 67 is for this mean right here. So now let us get the answer for this one and this one. That is, so the first one is mean minus 1 standard deviation. Remember, 1 is for care here. So you have mean minus 1 standard deviation. Mean minus 1 times standard deviation of 4. Okay. That'll give us students. 1 times, let me put it this way. 1 standard deviation, let me put the symbol first. Then we'll start putting the numbers. Minus 1 times standard deviation. Okay. You can see this one. I write it down here. Remember, this is times. Okay. So now I'm gonna have 1 standard. So you have mean. Our mean is 67. So you have 67 minus 1 times standard deviation of 4. And that gives us the answer. Let me write this down. 67 minus 1 times 4, which we can go to the decimals and get. So you have 67. So you have 67 minus 1 times 4 give us 63. 63. So our answer for that one is 63. So remember, this one here is for this. So we go here under it and put 63. Okay. Now we'll repeat the same process to get this one. So I'm going to have the same thing what we just did, but this time around, we make it plus sign. So we continue doing it until we get the answer to all the formulas. Now we put plus sign. So we can get this one here. So put plus sign here. So that our answer will now change to go to calculator and change it to plus sign. We get 71. Okay. 71. So that's 71. And that is for this one, because this is mean plus 1 standard deviation. That means mean plus 1 standard deviation. So that one give us 71 for that. So we repeat the process for 2 standard deviation. I mean, this one here and this one. So let's see this for 2 standard deviation. And then we'll have mean minus 1. You're gonna be something, just change it. Okay, let me see. We got mean. Okay. Minus 2 times standard deviation. Okay. 2 standard deviation equals 67 minus 2 times 4. See? So I'm gonna write this down. 67 minus 2 times 4. So I'm gonna put this on a calculator. 67 minus 2 times 4 give us 59. So 59, we go and put 59 here. 59. And we repeat the same process, except that this time around we use plus sign. Okay. We got before we can do that, the answer we got here is 59, which is for here. Remember, this is mean minus 2 standard deviation, and this is mean minus 2. So this is 59 here for us. 59. Okay. Okay. Now repeat the same process to get this part. Now, except that now this time around we change it to plus sign. Plus, change this to plus. And this to plus. So that this will change my final answer to this. So let's go to the calculator, change this to plus. Give us 75. Okay, 75. There's 75 here, and this is for two standard deviations. That means right here, 275 right there, 75. So this one is for that. The last step is to get the answer for this formula for the three standard deviation, of which we can do mean, okay, minus 3 times the standard deviation, okay, get the standard deviation, which means 67, Macmillan. Just give me 1 minute. All right, 67, 67. Oh, people are just jumping in. 67, 67 minus 3 times 4 standard deviation, okay, equal, so we got 67 minus 3 times 4. So go to the calculator and put this in. We got 67 minus 3 times 4, 55. I'll give us 55. Here you got 55. So you come here and put it. This is mean minus 3 standard deviation. This is where mean minus, so you got minus 3 standard deviation. So you gotta put it here, 55. Okay. Okay, then yeah, look at that. Okay. Now get the rest of them. So get this last one. Where we repeat the same thing, so that this time you use plus sign. Say put plus sign. And then plus sign here. So remove the final answer. So let's go to the calculator and change this so I can get that final answer there. Plus sign, change this to plus sign. 79. 79. So 79. 79. So that means this is for mean plus 3 standard deviations, and that is give us 79. So now we have gotten all the answer for all this. Now we are now ready to answer this question here that they asked us. The question was, estimate the percent of vehicles whose speed are between 63 miles per hour and 71 miles per hour. So we can now answer this now, since we have gotten the answer for all those formulas. See? So now the percent of vehicles at A, the percent of vehicles whose speed are between 63 miles per hour and 71 miles per hour. Look at 63 miles right here. Look at 71 miles. So between 63 and 71 miles, so that is between these two spaces. Let me yeah, between these two spaces. Let me show you with a line. So you're gonna be from between these two. See, it's gonna be between from, it says 63 miles to 70. I mean, from here to here, and that is these two. It says between 63 miles and 71 miles. So it's between 63 and 71 miles. You can see them right, this and that. So that means you're gonna add this 2%. 34 plus 34 is Okay. 34%. 34% plus 34%. And how do we get 34% and 34%? It is already in the written on stone that when empirical rule is involved, that this is how it should be. All the percentages are already there. So all you gotta do is to get your the answer from the formula and then trace it here. So this is from 63 to 71 miles, which is 34% plus 34%, which is 68%. So make it a little bit bigger. 68%. Any question to that? Any question? Any question? Okay, good. No question. So part B says, says here, suppose the number of vehicles in the sample is 75. Estimate the number of vehicles whose speed are between 63 to 71%, 63 miles per hour to 71 miles per hour. So in this case, we have a sample of 75 cars. So our N equals 75. Okay. So between the percent, we already have that percent as of between 63 and 71 miles to be 68% already. So if they are looking for the number of vehicles in the sample, the number of vehicles whose speed are between 63 to 71 miles per hour. What you gotta do is to simply multiply the two. Since we already have that between 63 to 71 miles per hour is 68%. So that the number of vehicles, okay, number of vehicles whose speed are between 63 miles and 71 miles per hour now becomes 75 times 68%. That means equal. Now, if you change this 68% to decimal, that means 75 times 0.68. 75 times 0.68. If you go to calculator, you have that's 75 times 0.68 is 51. Okay. 51 vehicles. Okay. 51 vehicles. So you got to write 51 vehicles. What 51 vehicles? Okay. Now, any question with that? Yeah, no question said, but that is very good. Now next question now is on that section. Say, in a sample of 25 additional vehicles, about how many vehicles will you expect to have speeds exceeding 75 miles an hour? Exceeding. Okay. Number of vehicles that will have speed exceeding that part C. Part C, N in this case, N is 25, right? N equals 25. Okay, and we already have the percent for 63 to 71 miles per hour to be 68%. But it's asking you for those vehicles that will have a percent speed that exceeds that. That will have speed that exceeds 71 miles per hour. Well, let's see, in this case, we don't have the percent really of those that exceeded that. So let's get the percent of that one. We said here, speed that exceeds 71 miles per hour. So we will go to our chart. You will see that I'm going to move this one here. Okay, this is 71 miles per hour. So the AC that will be from here. You can get from here, 71 from here up. See, that means 13.5% plus 2.35%. So that means, first of all, let's get the percent. Percent of vehicles. Okay. Percent of vehicles with speed. Okay. With speed. Exceeding 75 miles an hour equals, we have, like I said, if you look at the chart again, see from here, this is 71 miles, exceeding from the exceeding 71 miles per hour will be from here all the way to the end. That means 13.5% plus 2.35%. Let me write it down. 13.5% plus 2.35%. So gonna be 13.5% plus 2.35%. And that will give us the percent that has speed exceeding that. So you have 13.5 plus 2.35 give us 15.85. 15.85%. So I'm gonna put the 15.85%. 15.85%. So with this, we can now answer the question. The question was, in a sample of 25 additional vehicles, about how many vehicles will you expect to have speed exceeding 75 to 71 miles per hour? So since we have the percent, we can just get it right here. Okay. So percent number of vehicles with speeds. Okay, with number of vehicles with speeds exceeding that 75 miles an hour equals, multiply the two, because n is 25. I mean 25 times 15.85%, which is 25 times, when we change this to decimal, we get 0.1585, and that will give us our answer. Let me do it. 25 times 0.1585. We have 25. Okay. 25 times 0.1585 give us 3.96, which is approximately 4. Okay. 4 vehicles. About 4 vehicles. Okay. So about 4 vehicles. 4 vehicles. 4 vehicles. Okay. Any question? Okay. All right. Since there's no question, we can proceed to the next one, which is this one, Chebyshev's theorem. Now look at this question here. It says the average check at a local restaurant is $36.42 with a standard deviation of $8.15. What is the minimum percentage of check between $15.25 and $57.61? Now, it didn't tell us any assumption. He didn't say assume that it is normal or assume that it is symmetric or assume that it is bell-shaped. He didn't say that. That would tell me that it is, we're going to be using Chebyshev formula or theorem. So the mean is this, and the standard deviation is this. He said, what is the minimum percentage of checks? What is the minimum percentage of check between $15.25 and $57.51? So in that case, we need to get our care first of all. With that, we can now apply use the Chebyshev, because according to Chebyshev theory, excuse me, Chebyshev theory says the position of any data set lying within Kerr's standard deviation of the mean is at least 1 minus 1 over Kerr squared. That's 100%. That's what it says. So having given you this background before and then repeated it, we are able to jump into this formula. So here, the lower end is here. It's a between, what is the minimum percentage of check between $15.25 and $57.61? So the minimum is $15.25 and 5 cents. And the maximum is $57.61. So to be able to answer this question, we need to find our K first. And this is the formula for finding K right here. Okay. We use the find K. Upper end minus mean over standard deviation. Or you can use this one, lower end minus mean divided by standard deviation. So let us apply this for this first one. For the first one, it says this is the upper. Oh, this upper should be here. Upper is 57.61. Okay. And lower is 15.25. Okay. Now this is the upper one. So it means that here for that one will now become upper minus mean divided by standard deviation. And this is our mean right there. And this is our standard deviation. So upper mean, it means that upper, which is upper is $57.61, 57.61 minus mean of 36.42 divided by standard deviation of 8.15, which is right here, 8.15. And that gives us the upper end, the K. So let me write this down, put it on the calculator. I got 57.61 minus 36.42 over 8.15, and that gives me the result. Let me put it in the calculator. So taking you there, we have, you got 57.61 minus 36.42, okay, divided by 8.15. Give me 2.6 even, 2.6 even, 2.6. Oh, 2.6. I'll take you there. You can see the 2.6 right there. Now, as a check, we do the same thing with the lower end, okay? Here we have K equals lower, which is 15.25, 15.25 minus the mean of 36.42 divided by standard deviation of 8.15. And that, so just go to the calculator and put this in. The lower is 15.25, right? Yeah, 15.25. So 15.25. Yeah, 15.25. Or lower, 15.25. Give me negative 2.5 now, which is approximately negative 2.6. Negative 2.597. Negative 2.59. Negative 2.598, which is approximately negative 2.6. So it's negative because it's on the left side. Remember, you have left and right, I mean to say. So that means that, but this check now tell us that K is 2.6. Now we are ready to apply Chebyshev formula to answer the question: what is the minimum percentage of the checks between $15.25 and $57.81? So that means that the minimum percentage of checks between the minimum percentage of checks between these two values, one, you can get it by 1 minus 1 over K squared times 100, which is I'm gonna get this in the formula from the other workbook. So it's gonna be 1 minus 1 over K is 2.6. Okay, 2.6 squared times 100. Yeah, percent. So we're gonna go get this, apply this. I'm gonna copy this formula so I can apply it in put it on the other workbook. Okay, and we have here. So we got in that workbook, we're gonna use the formula. I'm gonna paste it on the formula. Okay. So one, okay, I pasted the formula right there. Make it bigger so you can see it clearly. Okay. Yeah. Okay, let's see. Equals, I got okay, 1 minus 1 over 2.6, which is 2.6. Oh, 2.6 squared. What is this gonna be? 2.6 squared. Okay. Times 100%, which gives us the answer for the minimum percentage. So I'm going to take you to the calculator so we can get this answer. Put them there. So we got okay, 1 minus 1 over 2.6. Okay, times 100. 85.2%. 85.2. 85.2%. 85.2%. So I'm going to copy this and paste it in our main workbook. Okay. 85.2%. So that you can see that the minimum percentage of check between $15.25 and $57.81 is 85.2%. Okay. Any question? If you have a question, ask it and I'll answer. Any question? Yeah. No question. That's very good. So let us continue then. Next question we have here is this one. It says, the one I want to answer here is this one here. It says, assume that the average age of an MBA student is 31.6 years with a standard deviation of 2.8 years. Calculate the z-score for MBA students who is 28 years old. Say B, use empirical rule to determine the age range that will include 99.7% of the students around the mean. C, use the Chebyshev theorem to determine the age range of the student that will include 94% of the students. The part D say using Chebyshev theorem determine the range of ages that will include 80% of the students around the mean. So as you know, according to this formula, it's a Z score. Well, according to this equation, the mean is 31.6 and the standard deviation is 2.8. Part A say find the Z score for MBA students who is 28 years. In that case, S is 28 years. So the Z score, to find Z score, remember the formula. The formula is Z equals X minus the mean, mean divided by standard deviation. So for this, our equation, we have our X as 28 years, mean is at 1.6, and the standard deviation is 2.8. So let me write them down. Mean is at 1.6. Standard deviation is 2.8, and our X is 28. So taking you there, we can have it put it worked out and then put it in our workbook. Equals, we have, yep, we have it, okay, you have this, S is 28 minus mean of 31.6 over standard deviation of 2.8. Okay. So the Z score is, so you got 28 minus 31.6 over 2.8. So that we have 8 here as, we got 28 minus 31.6. Okay, divided by 2.8. Negative 1.29. Negative 1.29. Negative sign means that it is below average. So I got negative 1.29. Okay. And so I'm gonna place it on our main workbook where the question was asked. So see, this is the Z score for that. Say, can we the Z score for the students who is 28 years? The student age in this case, how do you interpret this? The age of that student, the age of this student is 1.29 standard deviation. Below the mean age. Okay, so we answer part A. Now part B says using empirical rule, determine the range of ages for that we include 99.7% of the students. Well, to answer this question, you have to figure out what empirical rule said. According to the empirical rule, we have that we said 99.7%. Let's see what the empirical rule said about this number. 99.7. According to the empirical rule, let me see where it is. Empirical rule says that about 99.7% of values fall within 3 standard deviations of the mean. See, that's what the empirical rule said. about 99.7% fall within 3 standard deviation. So that will help us to answer this question where it says, use empirical rule to answer this. Say, determine the age range of that, determine the range of ages that we include 99.7% of the students. So I write here, according to the empirical rule, okay, about 99.7 fall within 3 standard deviations of the mean. About 99.7. So that means we're going to use mean, because it says 3 standard deviations. So you're going to use mean minus 3 times standard deviation for the lower range. Okay. And then we're going to use mean plus 3 standard deviation for the upper range. Okay. Change this to plus. So for this one, we got mean, which is 31.6 minus 3 times 2.8, which is the standard deviation. Okay. Let me write this down. 31.6 minus 3 times 2.8. So I'll take you to the calculator. You have you got 31.6 minus 3 times 2.8. That gives us 23.2. 23.2. In 3.2 years, so I'm gonna go there and put it 23.2 years. Okay. 0.2 years. Then repeat the same process here, but this time around you're using plus sign. So I'm gonna go here and put the plus sign for this. 40 years. 40 years, okay. So what it says 40. So you can see from here 40. So we have it here 40 years. So which means that about, because the question was determine the range of ages that will fall, that will include 99.7. So the range of ages, okay, you can say that's how you interpret it, this one. Interpretation of this. It says the range of ages, okay. The range of ages that will include 99.7% of the students around the mean is 23.2 years, 23.2 2 years, 2 to 40 years. So that's it for that question. Then we still have 2 more questions to answer there, which is part C, which says, using Chebyshev theorem, determine the range of ages that will include 94% of the student around the mean. So for this one, again, you go to Chebyshev, see what it says about 94%. Again, you have your mean as this, standard deviation is this, okay. Let's see what Chebyshev said for 94%. Chebyshev, for 94%, Chebyshev says this. It says, at least 94% of the mean fall within 4 standard deviations. That's what Chebyshev says. At least 94% fall within 4 standard deviations of the mean. So that will help us to answer that question. Okay. So Chebyshev said at least. So was for 94%. Chebyshev said this at least 94% of them fall within 4 standard deviation of the mean. So we're gonna use 4 here. In that case, we have mean, okay, minus 4 times standard deviation on the left side, okay. So equals, then on the right side, we're gonna use the same thing, but this time we change to plus sign. So this one will give us equals mean is 31.6 minus 4 times standard deviation. Okay, we have 4 times 2.8. Yeah. So we have this at 1.6. Let me write it down. At 1.6 minus 4 times 2.8 equals, get at 1.6. At 1.6 minus 4 times 2.8 give me 20.4. So I got 20.4. 20.4. Then I'll repeat the same process here, but this one we're gonna put plus sign here. Okay. So you got at 1.6 plus 4 times 2.8. So you go and put this, make it plus here. 42.8. 42.8. So that means that it says the question was determine the range of ages that will include at least 94%. So that the range of ages that will include at least 94%, the range of ages that will include at least 94% will now become 20 is 20.4 years to 42.8 years. Okay. Now, any question on this? Okay, good. No questions. So very good. So let's do the last section of that. The last question in that section is this one. So using Chebyshev theorem, determine the range of ages that will include 80% of the students around the mean. That is part D. Part D. Part D. Remember that our mean is still the same thing. Mean and standard deviation are still at 1.6 and 2.8. So that's what our mean is. Okay. Now, let's see what Chebyshev said about 80% of the of the population, at least 80%. So we'll go to Chebyshev theorem. We discover that it actually didn't say anything about 80%, which means that we are going to estimate our K ourselves using algebra. If you have said something about 80%, maybe like this one is said 94, the last one we did say 94%, so we're going to know that our K is 4. But this time it didn't say anything. That means we need to estimate our K by ourselves. So to do that, we now use algebra. So remember that Chebyshev says that at least the the position of any data value lying within K's standard deviation of the mean is at least 1 minus 1 over K squared times hundreds. So that would be the basis. That's the formula we're gonna use, okay, for estimating this K squared by ourselves. So we use that formula. According to Chebyshev theory, we have this formula here. Let me put it right there. Okay. So according to Chebyshev theorem, we have that the position of any data value, any data set lying within K standard deviation of the mean is this, at least that. So which means that we solve for this K. So then we have now, but this time around, they tell us that it is 80%. They give us the estimate of the percent as 80%, which means that we're gonna have this. I'm gonna show you how it will looks like on this place. You mean that, okay, 1 minus 1 over K squared, 1 minus 1 over K squared, 1 over K squared, 1 over K squared times 100. But this time they already give us the percent as 80%. So we got 80%. Okay. So we already have it as 80%. So I'm gonna copy this and put it there so you can see. Oh, excuse me. On the main workbook. So we're gonna use this as the basis for estimating our K. Part 4, right here. Part D. I'll have D twice. No, it can be twice. Okay, let me have enough room. So I'm gonna put it here. But I can start from here. So that means we have it at, see, that'll give us the idea of what we are looking for. So we're gonna solve this equation to get our for K. We're gonna solve it for K to get our K, you know. So writing this again, changing this percent to decimal, we're gonna have this here. When we write it, 80% to decimal, 80 divided by 100. See, look. 80 by 100 equals 0.8, which means that our equation now will now be changed to this. Okay. 0.8. Okay. So that will the second part, how it will looks like now. So we're gonna paste it here. Now we're applying algebra to this. So I'm gonna paste it here and then center it. Okay. So next thing is to start solving it. Now, next is to remove the parentheses. Okay. Which means that if you have this, remove this parentheses. 1 minus 1 minus 1 over K squared. 1 minus 1 over K squared. In 1 minute. 1 over K squared. What are my formulas? Okay, my equation formulas. Okay, good, they're out now. Okay. 1 minus 1 over, okay, for my formulas disappeared. Okay, good, they're out now. So 1 minus 1 over K squared. K squared is 0.8. So the parentheses are gone now. So I'll copy this and then paste it in the workbook. Then center it. so we can see what we are doing there. See? So now, here it has parentheses, then we remove it, come to this point. Now, next thing now is to, from algebra. Algebra say, if you're solving this, if you want this to stay by itself, subtract 1 from both sides. So we're gonna do, according to algebra, -1 on this side, and everything you do on one side, you do on the other side, -1 on that side. Then you draw your line, to now get the difference. So this one cancel out, this one cancel out. So you have only this one left now. Then on this side is 0.8 minus 1. We'll come to that. Let's say this one cancel, this negative one cancel. You have only this on the left side now. So -1 K squared. We got -1 K squared, negative 1 K squared. Okay, K squared equals now on this side we have 0.8 minus 1, and for the calculator we know that 0.8 minus 1, 0.8, okay, this 0.80 minus 1 give us negative 0.20. So we got negative 0.20, negative 0.20. And we can copy this step by step. Okay. We got it here, what we're going to have here, paste it here, and then, center it. Good. So at this point, what we are ready to do now at this point is now to make both of them positive. In algebra, to make them positive, we divide both of them by -1. So we're going to divide both of them by -1. Okay. Divided by -1. Okay, and divided by -1 on this side as well. Okay, by -1. Divided by -1. -1, and then by -1 on this side. So our now result will now become after divided by -1 is going to be positive of this. So our result will be if I put the line, so after this division, our result will now become so that means positive. The negative sign will disappear, become positive. Okay. Then go there and place it on that. So from algebra, we're using algebra here. See, this is what we have like. We're just trying to get the K. Once we get the K, we can answer our final question. Now, this time we're ready to flip it. Get the reciprocal of both of them, reciprocal of this and reciprocal of this. So K squared over 1, that means you're flipping this. You flip this, and you're gonna give us K squared. So you have we got and this you gotta look like this. So you have K squared over 1. Got K squared over 1. Yeah, K squared over 1. Okay, equals, we got our point. Got this point, 0.2. We flip this one, so 1 over 0.2. Okay, so I got 1 over 0.2. 1 over 0.20. So step by step. So that gives us this result that we have here. Okay. then center it. See, you can see step by step. Now, k squared divided by 1 will give us k squared. So we have what's happening is k squared equals, okay, now we have 1 divided by 0.2. So from our calculator, we have that, okay, 1 divided by 0.2 give us 5. So that'll give us 5 right here. Okay, 5. So k squared equals to 5. Okay, that'll give us k squared equals to 5. Okay. Right. So you can see right there. Now to find k, that's k squared equals to 5. To 5k, just k will now be square root of 5. So that means that our k now becomes k equals square root of 5. Square root of 5, and that will give us the square root of 5 from this calculator. Square root of 5 is 2.24. Approximately 2.24. 2.24. Okay, 2.24. So you got it as 2.24 for the square root of 5, which is 2.24. So that's our k for that. We got k as 2.24. Okay. So you can see how we follow this from this all the way from here down, keep solving, and get our k as 2. So with this now we have our k. We can now answer the equation of which says using Chebyshev theorem, determine the range of ages that will include 80% of the students around the mean. So using Chebyshev, you can we'll have our gonna be mean as usual, mean which is mean. I'm gonna copy it. Okay, mean minus, now for our k is 2.24. 2.24 times standard deviation of what's our standard deviation of 2.8? Okay, of 2.8. Okay, so 2.24d, not 2.24 our d standard deviation, my mistake. 2.24 delta, I mean to say, times delta, which means our mean actual mean is for this question is 31.6. 31.6. Okay, 31.6. 31.6 minus 2.24 times the standard deviation of 2.8. 2.8. And that will give us the first answer for that. So let me write it down and give you the answer right here. We got 31.6 minus 2.24 times 2.8. Okay. So you got okay, 31.6. 31.6 minus 2.24 times 2.8. 25.3. 25.3. Yes. So you got 25.3 years. 25.3 years. And for the upper side, we do the same thing. Let's say that this time around, you are using a plus sign. Put plus sign here. And then plus sign here as well. So that will change our final answer to, I'll put it here. Okay, you have plus sign. That is 7.87. So that's 7.87. That is 7.87, which means that the range of ages that include 80% of the students around the mean will be that. Range of ages that will include 80% of the students, and at least 80% of the students will be 25.3 years is 25.3 years to 37.87 years. Okay. So now, any question on this? Any question? Any question, class? Okay, so this concludes our data description. So we finished everything. That's why I mentioned in my announcement that finish homework 3 and 4. Remember, you have test 1 due this week, and that should be based on what you have done, covered. So that our next topic of discussion will be on probability. And then we will begin probability when we meet in class next week. Okay. So I'm going to put your classwork now so that I can solve it and upload it for me. Let me get the classwork question from here. Okay. The classwork.
Hello. Hello, Professor.
Yes, sir.
For one of the assignments, I completed it, but you said I did not upload it in Excel form. I'm not too sure how to do that. So how do I do that?
If you did it in Excel,
I gave it to you in PDF form.
No, PDF. Which assignment are you referring to?
This is.
Be excited for you. Yeah,
I'm not too sure.
We don't know.
Well, if assignment is done in Excel, you have to upload the Excel file.
I don't know how to do that.
The same way,
After spending years on the CW.
Hello, can you can you meet yourself, please?
Low budget ending that we all thought was lined up in the bargain bin at Walmart. I mean, no offense. I mean, none taken.
Is that person?
Your world renowned.
Is Macmillan?
Just told you. He's so
Macmillan.
about your prospects.
Macmillan, can you meet yourself, please? Yes, sir. Hello?
Yes.
Yeah. The same way you uploaded the PDF, that's why I upload Excel.
Yeah, I'm not too sure how to upload an Excel assignment. I usually just download it as a PDF and then send it to you, but
no. The assignment is, if you're talking about that one you have to do the assignment by typing those numbers in Excel and do the work on Excel, then upload the Excel.
Yeah, I did, but then I saved it as a PDF afterwards.
No, don't save it as a PDF.
Just
save it as an Excel, then upload it.
Okay.
Don't save it as a PDF.
All right.
PDF will not give you credit because I want to see the work.
Okay, got you. All right, thank you.
You're welcome. So now let me make sure that, let me put this in, don't go yet. Let me put this classwork, then check your names again for the attendance, and then you can leave.
One more thing. Can you upload the Word document too?
Which are the Word document?
This one.
The one we did this night?
The one we're doing right now.
Huh?
The Word document you're on right now.
Oh yeah. Okay. In that case, if I upload it, when you download it, you have to scroll down towards the end of the document. That's where you will see all this. Okay.
Okay. Thank you.
You're welcome. So let me put the classwork in first, and I can upload that. Classwork question is
the classwork due tonight or tomorrow?
It's due tonight, but I will accept it tomorrow if you submit it tomorrow. But
Okay.
It's due tonight. Let me see if I can get the question. The question is right here. Good. Oh no, not this one. What is it? No, not this one. Okay. All right, this is it right here. All right, put it right there. Your class opened. Open your class. Okay, more than. Yep. It's your classwork 6. I will change it to probability to empirical rule. Empirical rule. So this class one can do it on paper and then take a photo of it and upload it for me. Yeah, and that's it. Okay, now let me upload this one for the class handout. I'll save it. Yeah, you gotta scroll all the way down to the end. I can see it. Okay, so I'm gonna upload it. On the module, this module. Okay. Okay, we have. Yeah, I have to put it in file first. Files. Upload.
Can I send you your email because I don't understand how to do this thing in Excel form?
Maybe you don't understand how to do what in Excel form.
No.
Well, yeah, maybe if we meet in the class, I can show you how to. You haven't used Excel before. I actually explained step by step how to do it in Excel in one of those in the assignment. So I will say follow that step, or if you come to class, I can show you a sample.
Okay.
See that right, this is right here. Replace. All right, good. Now I'm gonna upload it here. Okay, fine. So it's here now. All right. So now let me finally check your attendance. Everybody see it. I've taken most of the people here already. Brown, Chebyshev, Vanderhorst, Hall. I got Macmillan, what's your Macmillan? I don't have that name here. With Macmillan, what's your last name? Macmillan?
Macmillan.
Yeah, what's your last name?
That is my last name.
Oh, Macmillan, okay, 28. Macmillan, right? MC. Okay. All
My
right.
first Tanisha.
Oh, okay. Watford, I got Watford, I got Simpson, I got Jurez, Rion H. Yeah, I got Rion H.
Harriet.
Lane, who's Lane? Okay, I got him. Who's Zach B? Zach B. The rest can go. Yeah, the rest are free to go. Who is Zach B? Zach B. You there? All right. I have to close it. I see you guys in the classroom. Have a nice night.
Wait, Professor.
Yeah, what can I do for you?
I don't know if you saw my message, but I was wondering if I could speak to you.
Go ahead, speak to me now. I'm listening.
Before she starts, hi, Professor. Could you maybe stop the recording so she can ask her question? But would you share the recording with us?
Can you say it again? I didn't hear you.
Would you share the recording with us?
Oh, the recording.
Yeah.
Want the video?
Please.
Oh, okay. I'll put the video. I will put it in. I will. Yeah, sure. I'll put it in the announcement. Sure.
Okay. Maybe and then maybe stop recording so that she can ask her question. But okay.
Okay. What's your number?
Did you mark me down for attendance?
What's your name?
Raphael.
Simpson.
No, Juarez. Raphael.
What's your last name?
Juarez. Juarez.
Sure. Can you spell it again?
Yeah, Juarez.
J-U. Oh, Raphael. Okay, yeah, I got you. I got you here.
All right, thank you.
You're welcome. All right. Now, who's the lady that want to ask me a question? I can can call you. Hello.
Oh, it was me, but could you like stop the recording?
Yeah. Well, if I stop recording, I will then I'll be done. Let me give me a number. Let me call you.
My number?
Yeah. Or you know what? Send it. Are you in my remind?
No.
If I stop recording, I don't know how. If I stop recording, I might lose everything I recorded. Yeah. So can you call me then?
Yeah, I can give you my number.
Can you put it on the chat?
Mm-hmm.
Any other apart from her, any other question other than her? Any other question?
Yes. Did you mark me up for attendance?
What's her name?
Jair Richards.
Jaya Richard.
Yes.
Yeah, I'm out to yes.
All right. And then another question. Did you never for the homework that's due this week or next week, you already put zeros in the grade book? Did you already go through that? Or it's like it says 0 already?
When you do the homework, it will change to your score.
Oh, okay. All right. And then for the Excel assignment number 1, you still didn't change my grade. It's still an E.
Yeah.
I mean, it's still like a
Yeah, like I say, those ones are already past assignments. So I will still grade them, but as soon as my time permits, because they already passed assignments, so I grade them.
All right, so you
as
just
soon as I get
all right, so you just
chance, yeah.
all right, so you never grade, you just haven't got the chance to grade them yet. Oh, regrade them.
Yeah, I haven't had the chance to grade them yet, but I will grade them.
Okay.
Eventually.
Okay.
Yeah.
Thank you.
You're welcome. Now I have to close and then so I can call make a call. See you guys next week. Why is it closing?